As we tackle another pattern, a really common one, let's have a look at what the factored form looks like, and then we'll again, as we did for difference of squares, work from the question, such as x squared plus 5x plus 6, to the factored form. So we'll expand these using FOIL. First is x times x, it's x squared. Outside, x times 4 is 4x. Inside, 3 times x is 3x. And finally, last, 4 times 3 is 12. So here we have collecting some like terms. I don't need a bracket there. Let me remove that. I have x squared plus 7x plus 12. Okay, we're usually comfortable moving in that direction, and if you're not, you're going to get an awful lot of practice as you check your factored answers. And what I notice here is that there's a relationship between the numbers in what will be the question, x squared plus 7x plus 12, and the factored form. How are they related? Let's start with the 12. If I look at the 12 in the unfactored form, I notice that it's a product of 3 and 4. 3 times 4 is 12. And those are the last two numbers. If I'm thinking of FOIL, first, outside, inside, last, the last two numbers in both binomials. Now 7 is the sum of 4x and 3x. It's the sum of 3 and 4. So what do we see? We see that the last term is the product of 3 and 4, and the middle term is the sum of 3 and 4. So our pattern will always look the same. The 3 and the 4 are chosen because their sum is 7 and their product is 12. Let's do one more expanding using FOIL. First, x times x is x squared. Outside, x times 8 is 8x. Inside, 6 times x is 6x. And last, 6 times 8 is 48. Okay, let's collect. We have x squared, 8 plus 6 is 14, 14x plus 48. What's the relationship between 14, 48, and 6 and 8? Well, if I add 6 and 8, their sum is 14. And if I multiply 6 and 8, that's how we got to the 48. There we go. What else is the same in all unfactored forms? First of all, I've written them all in the same order. They're in order of descending powers. The x squared term is first, then the x, then the number, the constant at the end. The other thing that's the same in all of these examples is that there's a coefficient of 1 in front of the x squared. This is the easiest kind of trinomial to factor. If the coefficient of x squared is other than 1, we need a few more tricks. But it's fairly straightforward if it's 1. We're doing the same thing. So let's start with x squared plus 5x plus 6. So I'm looking for two numbers that when I add them give me 5. When I multiply them, they give me 6. And that's 2 and 3. 2 plus 3 is 5, and 2 times 3 is 6. So I know what my two numbers in the binomial must look like. So x times x gives me x squared. So this is the same in each case. And then I know that one has to be a positive 2 and one has to be a positive 3. So that I end up the right point. Try it. Expand x plus 2 times x plus 3. You'll end up at x squared plus 5x plus 6. Got a whole page of these for you. Again, I strongly recommend that you pause the video, try some or all of them, and I'll catch up with you. What's different for these questions compared to the previous slide is that they're not all positive terms. Let's try one together. X squared minus 4x minus 45. Yep, it's a quadratic trinomial. It's written in the order we expect, so we don't need to rearrange it. And we do have a coefficient of 1 in front of the x squared. So we know it's going to have the same pattern in its factored form as the previous examples. This time, a little bit different. I need to worry about these negative signs. I need two numbers that, when I multiply them together, give me negative 45. When I add those two numbers, they have to give me negative 4. So I can think of 45. Take a moment. What are two numbers that would multiply together give you 45? Maybe you came up with 9 times 5. Yeah, 9 times 5 is 45. So now we need the 45 to be negative. So we either will take negative 9 and multiply it by positive 5 to give us negative 45, or we'll take positive 9 and multiply that by negative 5, and that'll also give us negative 45. Which combination here, negative 9 or negative 5, when added together, gives me negative 4? Well, since it's negative, that middle term, I know that it's the larger number, the 9 versus the 5, that will have to be negative. So I have x minus 9 and x plus 5. Second case, exactly the same. X squared, x, no x, great. Descending order, the coefficient of x squared is positive 1, so we're looking at the same pattern again. I'm looking for two numbers that when I multiply them give me negative 20, and when I add them, give me what? Give me negative 1. So one way to do this, and I didn't walk us through it with the 45, but let's try it with the 20 this time. What are the powers of 20? The factors, of 20. Well, 20 divided by 1 is 20, so 1 times 20 is 20. 20 divided by 2 is 10, so 2 times 10 is 20. 20 is not divisible by 3, but it is divisible by 4, and then I get 5, so 4 times 5 is 20. If I keep going, is 20 divisible by 5? Yes, it is, but that already gets me started up the other side. So these are my only options. 1 times 20, 2 times 10, and 4 times 5. Now I know that one of them will have to be negative because it's actually negative 20 that they have to multiply to. So right now I know I've got x and 4 and 5. One will be positive, one will be negative. When I add them, what do they have to sum to? They have to sum to negative 1, so it will have to be positive 4 and negative 5. Okay. Certainly, if you haven't stopped by now to try ahead, have a go at these numbers, at these last three problems. X squared plus 5x minus 24, or the factors of 24 that we need here are 8 and 3. And a lot of this is going to be guess and check. It's absolutely a great way to get started, to just write down two factors of 24 and then expand. When I'm expanding, I know I don't have to do the first and the last. X times x is going to be x squared. Okay, check. I chose 8 and 3 because they give me negative 24. Check. So what I'm really evaluating here is whether I'm correctly arriving at the middle term. So what I'm really doing is I'm checking that the outside, negative 3x, and the inside, 8x, sum to give positive 5x. And I have positive 8x and negative 3x. Yes. Check. I also get the positive 5x out of it. That checking of the outside and the inside is going to be important in just a moment. Let's finish off the bottom two. What's a little different here is that now I have to multiply to give positive 8. So maybe I'm thinking 2 and 4 immediately, but don't forget about the option of 8 and 1. But when I add those two numbers together, the 2 and the 4, let's say, they're supposed to give me a negative 6, negative value there. So I can't forget that while positive 2 and positive 4 will give me a positive 8, if I multiply negative 2 and negative 4, I'll similarly get positive 8. So in this case, I will need two negative values. And then finally, this is a case where I have to remember that to get to 9, I sure can use 9 and 1 and 3 and 3. And 3 might be the only one I come up with. So 9 and 1 is the important one here because it turns out that x plus 9 and x minus 1 is the only way to get that positive 8. So really remembering that the 9 and the 1 here are valid options. It's not so important if we're looking for a greatest common factor. That's not what we're doing here. In this case, we're looking for factors of 9 that when I look at their sum, I get my middle term, I have my like terms.